So this in today's session we are going to see 9, 10, and 11, and these topics are important for in term whatever are there in week 9, 10, and 11. So first of all, anyone have any doubt? No one have doubt. So in week 9 there are positive definiteness of the matrices. What is the use of that is we'll see maybe in some other course, but not here. But we should to know it at least what is a positive definite matrices, or graph and adjacency matrices are there, conic section is there, quadratic forms are there. So conic sections are nothing but you have already of the maths background, so it a kind of parabola, or you know ellipse, or could be a circle, or could be uh, uh, parabola, or ellipse or circle. This could be of any this kind of curves are called conic sections, sorry. So conics in 2D. So the most general case is here we can see the, like, any form could be written as all of you know it already. So forms are either could be, if you write as a circle, this could be of a square plus b square with some radius would be there for that, or maybe ellipse. eh, so x square by a plus y square b is equal to 1, or could be a parabola y is equal to x square is there. So if you see the conics are a kind of this one, like this, or maybe if you see the more general case, so these are the centers are origin. So here the centers are origin, either could be or ellipse, or could be kind of circle. These are for origin. But if it is not origin, what is going to be in this case? So in this case we generally thought of of this case as here we can see, this is the general case: ax square plus b xy plus cy square plus dx plus cy. So these are the some general equation of a conics in 2D. So you can say in two-dimensional conics are a square polynomial of two variable, as you can see it, square polynomial of two variable. Here it is as ax square plus b of xy plus cy square dx plus cy is equal to f. So once we have, then how we'll get circles, or what is going to be the center of it, what is going to be the chord. These all formulas already all of you are able to see it. Or if it is a more general case is given, how we will convert in in ellipse, what is going to be the major axis, minor axis. So you can see it here. This is one formula. It is mentioned. So these all you have seen already. You have to revise at least, so that you will be, these all needed. Why the revision sessions, or maybe the revisions are for that purpose, so that you can write in exam within some given some time limit, 1 hour time, within some time. So knowing the concept is not enough to pass the exam. You have to be right. You have to write it within the time constraint. So as you can see, if it is a ellipse, then if the major axis, minor axis, whatever we have, if both are same, then it will be, circle is, it would be, if it is anyone is missing, then it would be a ellipse. So these are the basic information already. This is just a recap from professor. Okay. Main is the new thing is here, quadratic forms and symmetric matrices. This is one important, because if we have a quadratic form, so how we will know that this will form a, you know uh, how we'll get a matrix related to that. So here is one form already mentioned, quadratic form. So here if you see, there is no constant added, only ax square plus bxy plus cy square. Each term, if you see, each term is of square degree. Here is a square degree 2, here is 1 degree, 1 degree, 2 degree, here is 2 degree. So each term here, if you see, each term is of degree 2. This form is called quadratic forms. Okay. So how we can write this form in the different manner, so that we will form a matrix. So how it is, see, if the quadratic form is given, then we'll generate a matrix that is going to be a symmetric matrix. So here if I will write in the form of, general case is there. So generally ax square plus, here is in the capital form, b of xy plus c y square. So this form of, a function, if a function is given like this, okay, so this is called quadratic form. Okay, you can, if somebody is asked what is quadratic form, so this is a quadratic form of a function, or this function is given in the quadratic form. So what is the use of quadratic form? The reason is we can use this to form a matrix. How we will form a matrix? So the matrix would be A, okay, and here see that the coefficients. Observe the coefficients, and this is B by 2, this is B by 2, and this is C. From this form, using this form to, we can generate a matrix here. Okay. So like, as you know, we have a linear transformation is given. Okay, T of xy, some expression is given. We can write using the basis and those all. We can form a matrix representation. So this one is a different. There is no use of matrix, sorry, basis, anything. We have given a polynomial in the quadratic form. A quadratic form of polynomial is given. We can write the matrix here. Okay. There is no use of like directly using the coefficients. So what is use of it? So use is very simple. Once you start studying calculus thing, so if you do the multivariable calculus, so in multivariable calculus, if you have more variable, okay, So using these, if your function is given a multivariable function is given, so using these quadratic forms, you can easily tell where is the critical points, at which point it have maxima, at which point it have minima. So many uses are there, but here is professor is just introducing what is a quadratic form and how we can generate a matrix from the quadratic form. But there is a broader case which is not taught, means that is not needed here in the syllabus. Otherwise there is a lot of use of the quadratic forms. Okay. So from this form we can generate. So generally the question would be asked, maybe a quadratic form is given. Okay, some quadratic form would be given, asked, and there could be a question that is this quadratic form is positive definite, or once you generate the symmetric matrix, is this positive definite or not. So what is the meaning of this positive definite? The meaning of the positive definite in the calculus form is, if your matrix is positive definite, then your that at that point, at some particular point where matrix is positive definite, then that point is going to be local minima, something is there, some more meaning of there. So but here we just are going to know it, what is a positive definite. So when we'll say, so from here we can generate always, so it would be in a two variable. Okay, so do no need to worry, generally in two variable it is asked, and you can, using this formula, you can generate the matrix which is a symmetric matrix. Once you have a symmetric matrix, now many times we have done, I'm not going to say what is going to be the eigenvalues, how to find that. You can easily find the eigenvalues, eigenvector. If the all eigenvalues is greater than 0, then it is a positive definite directly. If all eigenvalues greater or equal to 0, means either could be 0 or maybe positive only, so there, that is called positive semi word would be there, semi definite. Okay, and if it is if all eigenvalues, okay, less than 0, then in this case it is called negative definite, you can remember it. If all eigenvalues less than or equal to 0, means here some of them are maybe 0 or negative, in this case negative semi definite is there word. Okay, so you can relate it. So is this clear? Anyone have any doubt here?
No, sir.
Okay, so you, all of you used to remember one important property. What is that property? If your matrix is symmetric, no, so this is one formula to decide a form or a symmetric matrix is going to be positive definite or not. And if your matrix is symmetric, no, so there is a property that if you find the eigenvectors, okay, eigenvector, first find the eigenvalue, then eigenvector you will find. So whatever the eigenvector you will find, if you observe, okay, let's say v1 and v2 is the eigenvector of that. So if you observe, these two are going to be orthogonal to each other. This is a property of the eigenvectors of a symmetric matrix, which is already so which is that professor is saying the symmetric matrix and the orthonormal similarity. Means, right, once you find the eigenvector which is orthonormal, then if you do the diagonalizability of that. So one thing here is need to note that always a symmetric matrix, this is always, okay, always diagonalizable. Okay, you will always able to find that many eigenvectors, whatever the order is given. If it is, suppose this is a symmetric matrix of order 3 cross 3, you will always get eigenvalues and that many three independent eigenvector which is orthogonal, which is going to be orthogonal. So if you able to find the eigenvector, you can form P dp inverse, right? So this you are always P inverse dp. I think you are always able to get this P because you have three eigenvector which is orthogonal to each other, and this is going to be a orthogonal matrix because this P is formed using this v1 v2, right? It's formed by v1 v2. So here columns, if the column of a matrix is orthogonal, that is called orthogonal matrix. Or in different word, if you have a matrix, if you do transpose of it and multiply, you will get identity matrix. If a matrix have this property, then this matrix is called orthogonal matrix. And if you observe this matrix, whatever the column it have, okay, whatever the column, these columns are actually orthogonal to each other. So here in the P case, the columns are this vector which is orthogonal, so that's why it is orthogonal matrix. So that's why it is called not only diagonalizable, orthogonally diagonalizable. So that is what here, if you see here the answer.
So for our exam, in this case, actually, do we have to what is called as a find? I mean, derive the diagonalizable matrix D as well as the invertible matrix, which is the P inverse, right? In
Mm.
the case it's been asked.
So it may ask, but if you want to, time, you want to reduce your time. So if you at least find the eigenvector and write the P matrix. So P inverse, for the finding P inverse,
That
we are
shouldn't be a
not need.
problem. Actually, that shouldn't be a problem. But that will be asked, right? So
Yeah, that may ask. The
okay,
diagonalizability is an important question
okay,
for a symmetric matrix, but that may ask. But if you find the eigenvalues, eigenvectors, for you able to form the matrix P, and if you are not finding inverse, that is not going to be deduct lots of mark, maybe half marks, 1 marks. It is not going to be deduct going person going to be or going to
okay,
deduct more mark because at least we know that you know the concept.
okay.
Anyhow, if you are able to find the inverse, that is really good. So here, if you remember this formula, that would be good for you to uh, guess that which one is representing what, ellipse, hyperbola, or ellipse. But this, from this section, very less problem would be there. The important section is here: correlation and covariance matrix. This is one important topic from my side, and at least all of you, please try to do some problem on this. You may get some problem in interim from this correlation covariance matrix. This is an important topic of week 9. And what is a correlation covariance matrix? There is no advanced topic. It is just taught that what is a covariance. First of all, what is a mean median mode? Okay. Or here is, there is not important anything. Only just you have to remember this formula, this RXY, which is a correlation between x and y, okay, denoted by RXY, where what is written inner product between these two. If you are not going to remember this formula, that it doesn't mean here. Here you can remember this one, xi yi, multiplying xi yi in system. Maybe mean to say, if you have a data is given, maybe of this case, let's say a data is given like this: x and y, 1 2 3 4 5 6 7, 8, like this data is given. The answer to find the correlation between them. So how you will find? You can just write the formula: summation xi yi upon summation of xi square yi square xi square and summation yi square. What it means that multiply directly and sum them all. So upper part is going to be 2 plus 12 plus 30 plus 56. See that how it is directly multiplied. The upper part is going to be this one. The below part is square and sum them this portion. So this is 1 square plus 3 square plus 5 square plus 7 square. And not sum is there, multiplication is there, right? I added here. So here is not sum into 7 square and then root of yi. Just a second. Yeah, root of 2 square plus 4 square plus 6 square plus 8 square. If you just find this is going to be the, just need to find your correlation. That is your correlation. This is just a formula. The data is given and you can use this to find the correlation. If you want to connect with the inner product, these two are representing the same meaning. Norm is nothing but this formula. Norm of a formula is see that these are the same. Inner product between the data is going to be just xi yi. Okay, that is a correlation thing. So again, how we'll find that now once you have this correlation, how we'll find the correlation matrix. So to find correlation matrix, what you will do? We'll take data from here. What is this? You can take this vector, these vectors each time. Okay, we'll just take, let's say this is v1, v2, this is v3. Means your vector is, first vector is 1 2, second vector is 3 4. See that this is 3 4. Third vector is 5 6 7 8. Fourth vector is 7 8. So how the correlation matrix is formed? Writing like this: 1 2, and the second one is multiplying with the same. Means this matrix multiply with the same, you will get one matrix which is 1 2 2 4. One matrix you got. Again take this one, 3 4, and horizontally write this again 3 4, and multiply, you will get whatever the matrix. You can sum them all. For each you can sum them, and whatever the matrix you will get, that is your covariance matrix. If you see that the formula is this one, sorry, correlation matrix. This is your correlation matrix. So here these are actually just a formula you have to, in this at least you should to remember it. Mean and variance is written here. What is this? Mean is just summing them all data and divide by the number of data. So these are just formula all of you know already from the maths background. So you know this formula. The variance is nothing but the subtracted here from the mean and divided by again n. So these are needed some time to at least without practice you cannot do. You have to practice it. Means not do, you can do, but within the time limit the problem is. If you practice more you can do that easily. What is going to be the correlation coefficient between x and y? Bittu, I have asked one more question. Do we need to write only on one side of answer sheet or both sides? So, however they are instructed, please do that. Maybe some center have different instruction. So, this writing, these all maybe TCS center and TCS employee will instruct you how you will write there. Okay, whatever they are saying, according to that, you can write. So, no need to worry about that. How I will we used to write. It's depend on how at the TCS center how the TCS employee is saying it. So mean and this variance, there is one another concept. Centralized data means you have a data and you just subtract by the mean, you will get the centralized data. Okay, so you please remember this formula. These formulas are not going to be given in the paper. You have to remember it. Here is the covariance matrix formula. You can remember it easily. Otherwise, there is a different way to write it. You have a data is given, first centralize it. Okay? Once you centralize it, now just find the correlation matrix of this. It means this formula, this whatever we are actually finding. Find the correlation matrix of the centralized data, that is your covariance matrix, or you can remember this formula. There are two ways to remember it. And here is the more generalized case. If your data is not in two dimensional, maybe n dimensional, m dimensional. So how we can do that? Positive definiteness I already told just now. If you're able to find the matrix, eigenvalues, eigenvectors are the side. If all eigenvalues are positive, then your matrix is positive definite. All eigenvalues are negative, then your symmetric matrix is negative definite. Here is the way eigenvalues of a positive and positive semi-definite matrices are going to be very clearly it is mentioned. Theories are already mentioned, but if you just see from the above, means you're not do if you don't want to go in deep, just need to see what are these, or if you see how the assignments or maybe older, not older quizzes means already quiz and quiz 2 have done, how it is asked means theory we are not asking to prove it. Here these theories are actually to understand at least what is going behind the, if problems are given and if you are solving it, what is the theory behind that. So this is already I have told, this is not going to tell you. This is again a important topic, graph and adjacency matrix. So a graph contains two sets, a set of vertices and set of edges. Edges are pair of nodes, graph nodes connected by edges. So graph, already, if you think about the railway track, that is a kind of graph. So if I will say, suppose this is you have, so here if you say this is vertex v1, this is vertex v2, v3, this is v4, and these are the edges. These are the edges here. So if you write in the definition form how it is written here, it is written I1, I1, J1. So how we'll write the edges here? If it is writing, there is a problem with V1, V2, V3. So you can remove that and you can say this is 1, 2, 3, 4. So edges are 1, 4, 1, 2, 2, 3. 3 edges are there, so this is going to be. So the graph is represented like this. So there are so many representation. You can see in the representation how it is given in the lecture, or you know the path is or this form from this circuit graph, or actually the graph thing is coming from this circuit. The main idea is once you have a graph, so then forming the adjacency matrix. Many times how will form the adjacency matrix? So suppose this is a graph is given, how I will form the adjacency matrix? So what is the way is that you will just write the 1, 2, 3, 4 edges, 1, 2, 3, sorry, vertices 3, 4. Now if this graph, sorry, this edge is there, means these two are connected, means 1 and 4. So see, this is 1 here and this is 4. That means 1 would be here. That is what it is. If two edges are connected, you will write 1 here. Okay, our main matrix is this one. This here it is just
So it's
indicated.
always the edges are the horizontal and vertices are the vertical.
Sorry?
Edges are on the horizontal and vertices on the vertical, right?
No. Here the both are vertices I mentioned, right?
Oh,
This is
okay.
a vertices.
Yeah, both the vertices. Okay. Oh, the connection node. Okay. Okay. Right.
Actually, to write that, how you'll write the adjacency matrix?
Oh, the matrix
Because
formation.
formation. So 1, 4 have the edge. That means this is 1 here and this is 4. That means here it is going to be 1 entry. And 1 is connected with 2. So 1 is, if you just take the line 1 and 2. 1 and 2 means here this entry is going to be 1 here. Okay. And 1 is not connected with self, this is going to be 0. 1 and 3 is not connected, so this is going to be 0 here. So this is the first column is done. Sorry, first row is done. 2 and 1. 2 and 1 is connected. This is the entry 2 and 1. Is this connected? Yes. 2 and 1 is connected. So this is here 1. 2, 2 is not connected itself. 2, 3 is connected. Yes. Here is 1. And 2, 4 is connected. No. Are you able to get it, all of you? No. This is how you'll easily form the adjacency matrix. See here, if you see it, 1 and 2 is connected. So if this is formed because of to understand, you can write the above and this side as a vertices, and so that you 1 and 2 is connected means this is 1 here and this is 2 here. So 1, 2, see 1 is there. 1, 4 is connected, so 1, 4 is connected. He is 1 here. So you can write there as if you have difficulty. So let me. This is again the important topic. So if you see how it is written, so see that this is the graph we have. Change it different color. This is graph we have. Okay. And this is, so you can, if you want to, you for simplicity you can make it 1, 2, 3, 4. Here is 1, 2, 3, 4. Now see that 1 and 4 have this edge. So see that this is 1 here goes here 1 and 4. See that this is 1 here. So 1 is there. 1, 2 is graph have edge is there. So see that here is 1. And there is 1 is not connected with any other vertices, only with the two vertices. So see that at these places are 0 0. Now take vertex 2. 2 is connected with 4 and 1. So see that this is 1 here and this is 4 here, 1, and rest all 0 0. So by this way quickly you can write the adjacency matrix. Once you have find the adjacency matrix, you can follow the way to find the eigenvalues, eigenvector many times the same way you can follow that. So this is an important, and how many vertices are, so number of how many paths are there. So path is already mentioned. So what is a path? Suppose this is a graph with the adjacency matrix A. The ith jth entry of A power k is the number of path from the vertex I to j in k steps. So once you have an adjacency matrix, if you multiplying 2 times, okay, so whatever the entry you are getting, that tells you the from I to j you can get how many paths are there. Why is it tough to finding the eigenvalues in 3 cross 3 matrices? Yeah, that is what, that is only A minus lambda I. That is the only one formula is there, only one path, one method is there, simple method. If you have a matrix, let's say 1 0 0 0 1 1 0 0 1. This is a matrix you have. Want to find the eigenvalue, just do A minus lambda I, means 1 0 0 0 1 0. Identity matrix. Find the determinant of this matrix. You subtract here, this is 1 minus lambda 0 0 0 1 minus lambda. You can, let's put it here 0, and let's say here is 1, and this is 1, and this is 0 1 minus lambda. Find the determinant of this matrix. The determinant is going to be what? 1 minus. So here is, you will take this entry and expand with respect to that. So this is going to be this is, and this multiplied here. So this is 1 minus lambda and minus 1, and this is 1 minus lambda. This is lambda here, 1 minus lambda. This is 1 minus lambda, and this is lambda square minus lambda and minus 1 is equal to 0, equated to 0. So here this will give lambda is equal to 1, and this will give whatever the lambda may be, I would be there or a rational number would be there. You can check that is this complex number or complex root or a rational number. This is a quadratic, so you know how to find the root of quadratic already in maths 1, and already deal with that. So you can find, this is the way only which you used to do in 2 cross 2 matrices. Okay, finding the eigenvalues, eigenvector is already there. One important thing is the bipartite graph. The eigenvalues and eigenvector will decide, sorry, not only the eigenvalues only will decide if the graph is bipartite or not. So bipartite graph is what? By a graph which is, you can divide your graph in 2 parts. Like suppose this is, I have a this graph. So this graph is a bipartite graph. See that if, let's say, this vertices are 1 2 3 4. So see that if I will bipartite, if you take this set this vertices in let's say I'm taking a subset of vertices which is 1 2, and take this set, another set of 3 and 4. So these two are actually, there is no edge in between these two, but there is a edge between in these two sets. It means you can divide your graph in two different set of vertices where there is no edge between itself, but there is edge between the sets. So as here, this kind of graph is called bipartite graph. So if you have an adjacency matrix of a bipartite graph, then eigenvalues easily can tell your graph is a bipartite or not. So already how you can say that, it's already mentioned there. Okay. Here minus, if lambda is there, minus lambda should also be there. If such thing is there, then your graph is bipartite. If eigenvalues are kind of this one, 2 and minus 2, 4 and minus 4 is there, then your graph is bipartite. So you can remember this all there. Now in week 10, the circular matrix is there and Fourier basis is there. What is the circular matrix? Many times we have seen a circulation is here, given there. See that if you have H0, H1, H2, H3 till H7, how the circulation is there. Now you will take this H7 to here, and H0 will be now continue, H0, H1, H10, H6. Only the H7 is BB here. Now next column you will write, will take H6 to be top, and now below of it, these part will become. So H7, H6 this. So by this way the rotation will happen like this. This is called a circular matrix. Once you have a circular matrix, so eigenvectors of this circular matrix is called the Fourier basis. That's all. What is a Fourier basis? Fourier basis is the eigenvector, as here Fourier basis is the eigenvector of the circular matrix. That's all. Somebody's asked what is a Fourier basis? So Fourier basis is the eigenvectors. So person will ask what of which matrix? Eigenvectors of which matrix? So eigenvectors of circular matrix is called Fourier basis. That's all. If you find the eigenvector of this, which is a fixed thing, you know already what is the formula. Formula is there. We have to remember that formula. Where is that formula? And this formula, eigenvector formula. If you remember it always, that is your Fourier basis. I have seen when I was checking week 10, many of you are able to write the Fourier basis. So if you just copy, then you will not understand. If you just focus a bit, only a small thing, if you just focus that, you can easily get what is a Fourier basis. There many people used to get that exactly. I don't know, they are just copying or they are writing by you himself. So Fourier, so I'm just giving the definition here. What is a Fourier basis? Fourier basis is the eigenvectors of the circular matrix. That's all. And how we'll write this? So this is one UK general U0, U1, U2. Only this, if you write this, if you remember this formula, you can easily write the Fourier basis. That's all in this lecture. What is omega is, you can remember these all. Already you are doing from the complex, finding the roots all there. The next is important thing, DFT, discrete Fourier transform. What is a DFT? So once you have Fourier basis, using that you can write the DFT. What is a DFT? DFT is writing the matrix in the, you know, column wise in a matrix. Fourier basis. And temple thing, Fourier basis means eigenvectors of the circular matrix, writing them column wise, take the conjugate transpose, that is your TFT. That is your TFT. Now from here onward, you have to remember these formulas only. How will find the eigenvalues of circular matrix? This is the formula. Take the first column, write H0, H minus 1 WK, H n minus 2 W2 power K. Or here, H0, H1, not W, this is called omega, I'm wrongly pronouncing it. So omega power minus K. H2, omega power minus 2K. H3 or Hn, omega power minus n minus 2K. So if I will write the, uh, let's say I have a circular matrix is this one, 1, 2, 3, 4. So next column is going to be 4, 1, 2, 3. Next column is going to be 3, 4, 1, 4, 1, 3, 1, 2. Next column is going to be 2, okay, 2, and then 3, 4, 1. This is how you will write the circular matrix. What is the eigenvector with respect to that? So first eigenvector, which is 0, use 0. What is that? 1, 1, 1, 1, 4, 1, 1, and then next is 1. 1 upon root. What is that? Root n or maybe n, you can check the formula. I think, oh yeah, 1 upon root n. So means 1 upon root 4. What is u1? U1 is 1 omega u1. So for general case, if you write, then easily you can write. So let's say uk is there. So uk is 1 omega to the power k, omega power 2k, omega power 3k, omega power 4k. Once you write the general case, if you remember this one, now you can generate all. Omega 1, so 1 omega square
Omega.
omega cube. That's all u1. If you write u2 is going to be 1 omega square omega power 4 omega power 6.
6.
1, 2, 3, 4, 5. So this is not going to be there. So this is how you can easily write the eigenvectors. If you want to write the eigenvalues, so eigenvalues are going to be the hk. You just remember hk, right? So sorry, hk, sorry, lambda k or whatever the eigenvalue lambda k is denoting by lambda k is going to be, take these entries. So 1, 1 plus, this is your h0, right? This is your 3, 4. This is your h0. This one is your h0. This is your h2. This is h3, h4. So how the formula is? H0 plus h1 omega power minus 1 plus h2 omega power minus 2k minus 1 minus 1k plus h2 h3 h3 omega power minus 3k. That is what the formula, right? Yes. Plus h4. Oh, I'm writing down h0 h1 h2 h3 only till h3 is there. That's all. So 4 terms are. So now if you write lambda 1, lambda 0 is h0 plus, so h0 is 1 plus 2 time omega, omega power minus 1, sorry, omega power minus, so this is 0 plus h2 omega power
0, sir.
minus 2. So what is going to be 1 plus 2? Just sum them. The first eigenvalue is going to be, I think, this just sum. Correct? Yes.
Come on.
Sum of the, this is 1 plus 2 plus 3 plus 4. Now next is h, sorry, lambda 1. Lambda 1 is 1 plus 2 into omega power minus 1 plus 3 into omega power minus 2 plus 4, sorry, 2 into 1, 1, 2, 3, yeah, 4 into omega power minus 4. Similarly, h2 2k will be there, so 2 time multiply whatever the formula is there, exactly. Just remember the general case, replace by k 0 1 2 3, replace k by 0 1 2 3, will write the eigenvalues eigenvector easily. So this is your Fourier basis. Somebody's asked find the Fourier basis of r to the power 4, so this is your Fourier basis. Somebody's asked write the dft. So dft is nothing but write the eigenvectors here, 1 1 1 1 omega omega blah blah blah, whatever the eigenvectors are there, and Hermitian of it. This is your dft. So within one concept, so many things: Fourier basis, eigenvalues, eigenvector, dft, all are covered within one. And this is one important. So no need to even calculate a lot. If you just write the expression, that would be no, at least for us to know, you know the these all properties. The expression maybe reduce half marks. Yeah, there is one endpoint DFT. What is endpoint DFT? Either you can remember this formula or this formula. These are formulas. If you remember it, what is the DFT? See that these are the eigenvalues. If you remember, these are the eigenvalues formula. Is it? Is this eigenvalue?
Adding that will
Yes.
give that actually.
Sorry.
Adding that on a square, dividing by square root of n gives the length of that actually.
That's all. If divided by the square root, that will become your. See that if you see the root, this formula h0 h1 omega 1, and see that here the formula h0 h1, it's the same r divided by only just root. So endpoint DFT is your, you can easily get that. So try to match it. These all formulas are important. Okay. Now the normal operators are there. What is a normal operator? A normal operator is one thing is there. If you find a t there, okay, somebody says, is this t, is this operator is normal or operator or not? So first find a t star which is adjoint of it, and take the compose of 3 star t. If it is t star commutating with respect to this one composition, then your operator is normal operator. If your matrix is given, okay, find the, if matrix A is given, find the Hermitian of it. And if A Hermitian is communicating with each other, then your matrix is normal. That's all. That is your normal matrix. The whole theory is only on this thing. And this is one proof of it already. the normal matrices have some property that if you, this is the only general property, or in the matrix case is this one. Now direct question would be asked, some matrix is given, is this matrix is normal? Only just need to choose, only need to do the Hermitian communicate to each other is the same, then say this is a normal, if not then not. One property is there with respect to normal is this one, TV is equal to T star V. This is one important property, means so this is one property of normal matrices, and that's all. Now if you are not looking any content, that would be enough, because question would be asked directly from the normal case. Some properties are there, their eigenvectors are going to be orthonormals. For the properties you have to look at least. Yeah, week 11 is not tricky, just the formula. So 9, 10, 11s are actually full with the formulas. If you remember the formula, you can easily do.
So I have questions regarding this tomorrow's exam on the end term. Is there any proportion of number of questions or anything else related to the weeks, or equally spaced?
So there is no direct relation with particular week, means week 9 contain
I mean,
5
like
questions.
later on, like 8, 9, 10, 11, or whatever, that is have more concentration compared to the old one, or something like that, or it's not like that.
So suppose your paper is up for 100 marks, so you can assume 45 to 55 marks from 9, 10, and 11, and
Okay.
one to get would be from
The
maybe of
whole 8 weeks actually.
55
So
marks or 55 marks.
thank you, sir.
Now we have some vector, very specific kind of vector spaces. So here some vector spaces are, which are, now we are going to deal with infinite dimensional vector space. Till now we are done with R5, C5, some 5 dimensional, 10 dimensional, 1,000 dimensional. But here now you have infinite dimensional space. And what kind of vector spaces you have? A sequence vector space or functional space, polynomial spaces. So there are two specific here taught. One is a sequence space. So what is a sequence space? Sequence space is, here the definition is given. If sequences are convergent, addition and those all will be as usual as you used to add coordinate wise. Where is that sequence space? Sequence space is this is the function space. I think it is not in this lecture. Maybe in the next lecture. Means convergent sequences. We are going to think about a sequence which is convergent. But series means not only a series is going to be convergent series. Then that is going to be your sequence space. And what is a function space? See, L2 here is a sequence space. If you're taking the modulus of it and square them and summing them, if this sequence is convergent, that this sequence is going to be in the sequence space, a vector of a sequence space. Here is we are going to, so sequence spaces is not that much important. Here we are going to look at the function space. So function spaces are those space which contain the functions, but a very specific type of function, means it is integrable within some interval. So function space L2, where the domain is A to B is given of the functions. So if the function is integrable within the given domain, okay, where the integrable is integration is taken the modulus of it. Okay, if integration is exists, then we'll say is the function space L2 space. So the question is why these are all important. The important thing is we are going to write these functions in the some Fourier series form. And how we'll write? So this function spaces are actually contain some basis, orthonormal basis, sine cos functions. This is which is here, orthonormal basis, or we can see it. I think this could be here. So here it is tells how to find the norm of a vector, so which is nothing but the integration. So if you have a function is given, okay, let's say I have given a function fx is equal to x square from a to b. So norm of the function is nothing but integration of a to b, means if you suppose remove a to b which with 1 2, so here is 1 and 2. Okay, integration of 1 to norm square. So norm square is going to be integration 1 to t to the power 4. Square is already there. So t just changing the variable, or if you have problem with that, you can write x to the power 4. You can write remove that. So whatever. So let's say this is fx. So either you can let me do with this fx. So this is going to be this one dx. So whatever this going to be, this is your norm. So norm of the function. Okay. So but there is one thing is that where I want to show you infinite dimension space in this one. Okay, again the gram is with professor is teaching. Means here I can write that. So this sine 2 pi t, sine 2 pi t, cos 2 pi t, cos 2 pi l t. L means L0, L1, L2. So this will form the orthonormal basis. This will form an orthonormal basis of this spaces. So I can write this function, this function in this series form. That is your Fourier series. What is a Fourier series? I have some function is given, I can write in this function, because this function can expand, right? Basis is expand all the, or basis or any vector could be written as the basis sum of the basis element, some linear combination of the basis element. So that is what it's happening. So I have some function xt is given. I can write sine a0 plus a1 sine 2 pi t some plus cos 2 pi t. Something is there means I am able to write this out in the form of sine cos 2 pi t. So here these all actually why I'm not telling or why I'm not writing, because here only the formula, only just formula. Say that orthonormal basis is what I mean to say, cos 2 pi t, cos 4 pi t, 6 pi t sine. These are the orthonormal basis. Gram-Smith process is there. Last time I was telling about what is a Gram-Smith process. If you want to see it, the professor is already solving some problem on that. So if you have this orthonormal basis, you can think about the span. Span you can think that is from a subspace of this L2021. And Fourier basis or Fourier series is just projection of xt on this span. What is a Fourier series of xt? Fourier series or partial Fourier series is just the projection of xt on these bases. That's all. That is written one word. Last time also when I was taking week 11, I said what is a what is a Fourier series or partial Fourier is just a projection. Projection on these vectors. So just recall that your projection formula. Say that what is this is the projection. Next is the partial Fourier is just projection. Either you can remember this formula, or these are some examples you have, or you can see it here. That is why this here is the projection is there. So this is the projection on xt on this basis. That's all. Either you can remember this formula on between 0 to t interval, or whatever the formula you can remember. Means if you don't want to remember, just remember the projection thing. We are projecting on the basis of whatever is given. At least 0 to 2 you should remember. Means this formula is important, because generalizing is not, it is a kind of tough, but 0 to t is most probably it may come. You can remember this formula, which is of this one. In the more clear form is written this one. Xt is given. I want to write the Fourier series of it. So this is so these are actually professor is telling this is how, what is the mean of it. These are actually time consuming and have to write. Without practice you cannot. Complex Fourier series is again a formula. We need to remember that formula. The final formula is this one. If you see it, this is the final formula. C0 C1 e power I e j 2 pi k t upon t, where each term could be generated by this. At least in exam, if you write the formula, that would be enough, because now next thing is you just need to calculate the each term. Very clearly, professor is solving it. So this week 11 is full of formula. Nothing is more. There is no theory thing. You just need to remember the formula. We have polynomial. Sorry, a Fourier a function is given. You just need to write the Fourier series of that. Anyone have done some problem on this? Can share. Without solving, without practice, you cannot. Do anyone have solved something? If the power is 3 is given, that means in that case, guess method is there. Means at least, already it is in 12th standard how to find the root of polynomial. If you have, let's say, x cube, x cube plus 2x square plus 3 is given. I want to find the root of that. Means you will take this term. Means this term you take, means 3 is nothing but 1, 3, or only this one. So means trial and error method. If you substitute minus 1 plus 2, means if you assume x is equal to minus 1 and substitute in this, if you are getting 0, then done. If not, then try with the minus 3, try with the 1, and try with the 3. In trial method, take the negative or positive of each term in this and substitute in that. Means trial and error. Trial and error is there if the degree is 3 or greater than 3. Okay. Anyone have any doubt? Anyone have any doubt in mock or anywhere? Okay. No doubts. No doubts means, or if you're not trying it, if you have a doubt, then surely you may ask maybe a problem or any theory.
I think we should be okay, sir. Let's see for tomorrow.
Yeah. Okay.
So thank you very much, sir.
Okay. Thanks, everyone. Yeah, tomorrow is your exam. All the best and
Sure,
best of luck both
sure. Thank you very much, sir.
exam. Okay. Thanks, everyone.